Hey everyone, this is Professor Wei here. In this video, I want to walk you through an example problem of the application of a Python NumPy library, which we discussed in class. All right, so first thing first, let me share my screen. So during our lecture, we talk about some basic features of NumPy. It is a library that allows us to implement numerical computation in Python. It's different from the data type of a list, where in a list you cannot, mutate the substance within the list. If you want to implement computation like uh, so something like a vector, you have to use the array format data type. For example, if you have an array of 1, 2, 3, 4, and you want to take the summation of two identical arrays, you will get, let's say, array plus array you defined. You will get, let me load the library in the first place. Sorry. Uh, you will get 2, 4, 6, 8. Okay, so anyway, the point of this video is to let you guys to work on an exercise of capital budgeting. So essentially, you are going to evaluate the feasibility of a project with a time span of 5 years. All right, the initial outlay, the initial investment is 150,000, and you have a 5-year cash flow sequence. Okay, 40,000, 50,000, all the way to 80,000. Let's say we have a discount rate of 10%, weighted average cost of capital. You have to calculate the NPV of this project using the NumPy array, which we have seen in class. Okay, so I know for sure all of you guys know how to discount cash flows to the present and how to calculate NPV in your Finance 101 class. Essentially, NPV is the dollar return to measure the feasibility of a project. Essentially, you are going to discount back all the future expected project cash flows to the present and compare that discounted value to the initial investment to see if you have a positive dollar return to the shareholders. If the NPV is greater than zero, you're going to take the project. Otherwise, you're going to turn it down. So under the context of this exercise, we have to draw the timeline. We have to discount back every single one of these cash flows to the present, and then take the summation of those discounted cash flows and compare that single number with this 150,000 to see if we have a positive NPV. Okay, so that is our objective. Now let's work on the problem using the knowledge we developed in class. All right, so first thing first is to load the library. We are going to primarily using the NumPy. All right, so we also want to define the cash flows. All right. So we are going to work on the problem using the NumPy array, which we talked about before. All right. So the first cash flow would be the initial outlay or initial investment. And that is given as an outflow of 150,000. All right. And then we also have the project cash flows in a form of a NumPy array. Remember the syntax, we need to use uh, the array function under the NumPy library. All right. So essentially everything, within the square bracket is a list. Remember we talked about that. If you look at the type of this data format, it's going to be the list. And if you look at the NP array, that will give you the n-dimensional NumPy array. Okay. So we've defined a cash flow, and now the third input parameter will be discount rate that is at the level of 10%. All right, so what's going to be the next step? What we want to do is to calculate the NPV using the formula, all right? NPV formula. By saying fat formula, I would say, well, it's not that accurate. We are actually apply the formula under the framework of a NumPy array. Okay, so the first thing we want to, when it comes to the computation, we have to mentally, draw the timeline of the cash flows. All right. So what's the timeline? It's 5 years, right? If you're going to calculate this question in the Excel environment, you have to draw the timeline as we did many times in the class, right? 0, 1, 2, 3, 4, 5, right? So the length of this given cash flows will be the number of years, and that is, there's a function called the length. So you can see the years you derived from this thing over here is 6. This is because you have a starting point of 0 over here. So 0, 1, 2, 3, 0, 1, 2, sorry, 1, 2, 3, 4, 5, 6, 6 cash flows. Right? Because the counter starts from the initial cash flow is counted as 0. So there are 6 cash flows in the entire cash flow array. Okay, you can actually define a variable, let's call it n, to capture the number of cash flows. But let's say if we do not have that variables, you can just calculate the number of cash flows within the cash flow sequence. Okay, there is another function I want to introduce. Actually, we talked about that in class, and that is the A range under the NumPy library. So you can calculate the time periods. And that is the NP A range. Of years. So essentially, you are generating a cash flow sequence of specified length. All right. So the counter starts from 0. So you have 0, 1, 2, 3, 4, 5, 5 numbers that allows you to index each one of the cash flows. All right. We are going to use the time periods to capture the time points of each one of them and discount back all the cash flows. All right. So when it comes to the discounting, we have to sort out the discount factor in the first place. All right. So to discount back all the cash flows, we have to sort out 1 plus the discount rate to the power of course, the time periods. Right? So what is it? If you print out 1 plus the 10% times the time periods each time, you will end up a 1 by 6 NP array. right? So these are actually 1 over, oops, 1 over the discount rate to the power of time periods will be the discount factors you're going to use to discount back all the cash flows, right? So to sort out the cash flows, discounted cash flows, we have to apply the discount factors to the cash flows we defined. Okay. So now think about what is the cash flows over 1 plus the discount rate to the power of time periods. Well, that's essentially the discounted values of each one of the project cash flows, right? It is the NP array that captures the cash flow sequence of the project for the discounted cash flows of the projects, right? So if you want to come up with the summation of the discounted future expected cash flows, you have to take the summation of these discounted cash flows. All right. So this 70,000, this number captures the present value of all the future cash flows of the project. So the present value of 40,000, 50K, 60K, 70K, 80K. All right. And of course, you have to take the difference between the discounted value of project cash flows and the initial investment of the project. Because I have already defined the negative sign over here, so I just need to take the summation. All right. Now, what is the NPV? That's essentially this thing over here. Okay.